Hello students, welcome to the next lecture on the mathematics. Today we will discuss about polar coordinates. Myself Dr. Harish Garg. You can simply follow my YouTube channel. The name is Dr. Harish Garg. Now what we have studied so far, we already know what is the Cartesian coordinate system, which is represented by x, y. Now in this lecture we will try to learn the concept of the polar coordinates, which is denoted by r, theta. Now the first question that come in your mind, moreover in each of the students, is there why there is a need of the polar coordinates. If we already know the Cartesian coordinates, then this question will definitely come in you as well as in the other students. Then what is the concept behind that, why we need of the polar coordinates? As we have already discussed the Cartesian coordinates in my playlist Mathematics 1, you can see the limits of the several variable, continuity, chain rule, all about the Cartesian coordinates. Then why there is a need of the polar coordinates? So now in order to answer this, let us consider this simple example. If I simply write you, can you draw the graph of y is equal to x square? That's very simple. You can simply draw y is equal to x square like of here. If I simply call you sine of x, you can also draw the graph of the sine x. But can you draw the graph of this curve? It is not an easy target. It's not an easy for you. You can draw this graph within a fraction of a second. But if you try to convert this equation into the polar coordinates, then it will be quite easy as compared to the Cartesian coordinates. What will happen if you convert into the polar coordinates? If you convert into this equation into the polar coordinate, you will get as simple theta is equal to r. So as it's simply, remember that this theta is r is not be like of y is equal to x. You can't say that you can graph of this. It is not true. How you can draw the graph, that we also see in this lecture. From here you can see the graph of this function is much easier in the polar coordinates than of the Cartesian coordinates. How you can draw the graph of this? For example, here if I vary the value of theta from 0 to 2 pi, then the graph will be here. We will learn also how you can draw this graph in our next lectures are there. If you draw the graph from the interval 0 to 2 to 4 pi, then the graph will be here and so on. So you can see the shape of this graph is a spiral nature. So we call the graph is my spiral. One more example I can provide you. Can you draw the graph of this function? It is not an easy target because it is not possible you can write this function as y of fx. Can you find the value of the y easily from here? It is not possible for you. So it means it is very difficult. You can draw the graph or sketch the curve in the xy plane. But if you write this equation into the polar coordinates by using this transformation, if you substitute x is r cos theta, y is r sin theta, then the equation will be my here. And it is much easier. You can draw this graph in a very simple manner. But remember that it is always not any easier you can draw the polar curve than with respect to the Cartesian coordinates. For example, if I say this is my polar curve because it involves the r and theta, can you draw the graph of this? It is not an easy target. But if you convert this into the Cartesian coordinate, and you can see the equation will be xy is equal to 3, and you know what is the graph of the xy is equal to 3, that is a rectangular hyperbola, and you can easily draw in the Cartesian coordinates. So what is the purpose of this is, you can always use the polar coordinate. You can use the polar coordinate when you feel that it must be easier than of the Cartesian coordinates. Now the question arises is, what is the polar coordinates? Now question arises is, what is the polar coordinates? How you can define that? That's a very simple. You just consider the one axis. The origin is called as the pole, and this initial, that is x-axis, is called as the initial ray. If you consider any of the point, if you consider any point in this space and consider OP as my initial ray from here, then the distance between the O and P is denoted by R, is called as the directed distance. Why we call as the directed? Is a direction. It is direction in this here, and theta is the angle which makes a line OP with the initial ray. You remember that we always move in the counterclockwise direction. Then the coordinate of this point P in the polar form is written as r, theta, where r is the distance of this, theta is my counterclockwise direction. So remember, r is my directed distance from the origin or from the pole to the point, and angle is the directed angle to the initial ray from to this line OP. Here you must note that r and theta both can be positive or can be negative. What is the meaning of the r positive? R positive means if you are measuring the distance in the direction of the OP. R is taken as positive when you taken the direction in the direction of this, because you can see this is the direction inside here. So on this line it is a positive, but if you measuring on this side, on here, then this is my minus of r. So that is, r can be taken when you direction opposite to the direction of theta. This is the direction of the theta. If you take the opposite, then it is a negative. When the theta will be positive, theta is positive when you measuring in the anti-clockwise direction, then it's a positive. But if you measure in the clockwise direction, then it is a negative. A very simple concept. For example, here, can you indicate this point on the polar coordinates? Remember, whenever there is a representation of the point, you first always consider the angle. Always draw angle on the plane. This is the 0. You can see this is the x-axis. This is the y-axis. So in terms of the angle, it's a 0, 90 degree, 180, 270 and so on. What is the pi by 6? Pi by 6 is my 30 degree. So this is a line of the 30 degree. Fine. And this is the angle of pi by 6. Now you can see r is my positive. So since r is positive, so you have to measure on from the origin to this line. So what is the r? If I say this is my 3, so the point will be my 3 comma. So if I say this is my p, this is my o, then what is the meaning of that? This OP is my 3 and pi by 3 is here. Now you can see about the 4 comma minus pi by 2. Again, this is 0. So you can see this is my plus pi by 2. This is the counter clockwise direction. But we need a negative. So we will move as a clockwise direction. So this will be my minus pi by 2. Now you want to make as plus 4. So since we are needing on the minus pi by 4, so this is my positive, this is my minus pi. So we can take on this side as r positive and on this side as a r negative. So we can consider this as a positive r minus pi by 2. Similarly for here, firstly this angle r is equal to 0, that is on this line. This is my r is equal to theta is 0. Since r is my positive, so you can see this is my 3 comma 0 is the right answer. Here pi, this is my pi, so you are measuring on this side, this is my pi. On this side r is my positive, while on this side opposite of this r is my negative. 1 by 2, so 1 by 2 lies here is a positive, so it is 1 by 2 comma pi. If I consider here next example, you can see the r all are my negative. Firstly we can draw the pi by 3. This is my pi by 3. Now you can see this is the direction on this line. So here r is my positive on this side, while on this side r is my less than 0. So how you can do that? So on this side r is my less than 0, take minus of 2 here. So this is my minus 2. So I can write this value as here. This is my minus 2. So either you can write like of there, or you can simply write, you can simply dark this line. This is called as the minus 2 comma pi by 3. How you can draw that? Again, firstly you have to draw this pi by 2, that's a positive pi by 2. So you can write this is my positive pi by 2. R is my negative. So on this side r is my greater than 0, while on this side r is my less than 0. Fine. So r is negative, so this is my pi by 2. R is my minus negative, so this is my minus 3. So you can write this as minus 3 pi by 2 is the right answer. On this side 3 pi by 4. What is the 3 pi by 4 is? 135. So how you can write the 135? This is my 135. R is my negative. So on this side, this is my angle. So this side R is my positive. This side is negative. So this is my minus 4 is 3 pi by 4 is the right answer. So this is the way you can represent the points on these polar coordinates. Now look at this one. So here some are positive, some are negative are there. Firstly, you can draw this pi by 3. This is my pi by 3. This is my negative, so you have to take r on the negative side. So this is the line, only this is the line which represents the minus 3 comma pi by 3. So you have to remove the other lines. On this line, this is a minus pi by 3. So since angle is negative, so you have to write minus pi by 3 on this side. You can see that minus pi by 3, what is that? It is nothing but my 2 pi by 3. That's the same thing. You have to add pi on the both sides. If you add pi, it will be here. So this is my minus pi by 3. What is the meaning of that? On this line, because it's a minus pi by 3, r is my positive, and on this side r is my less than 0. But here we need a minus 5. So minus 5 lies on here. You can take the 5 distance, you will get as minus 5 comma pi by 3. Here you have to write as a minus pi by 2. So this is my plus pi by 2. This is my plus pi by 2. How you write as a negative? So this is my minus pi by 2. And here r I consider as a negative. So on this side, on this r is my positive. So this side r is my less than 0. So I can take this is minus 2 comma pi by 2. Similarly on this side, this is a minus pi by 4. Firstly, always draw the angle. So what is a minus pi by 4? You have to write this is my minus pi by 4. This side is r is my positive. This side r is my negative. So r I need as a positive. So this is the line of, here is the correct answer. Now what is the result of that? The polar coordinates are not always unique. What is the meaning of that? It means we can found the one point here, one more point is the another coordinates. For example, the angle, because there are the two coordinates r and theta. So firstly we will consider that angle is not a unique. Look at this point. It seems to be that these 2 points are different, but actually in the polar coordinates these are same. How? Look at that. If I draw this point on the graphically, this is my here. If I just write this is on my, this is my r is 0, this is my pi by 2. I can write the pi by 6 line. Since r is my positive, so this is my here. Now can you say, look at that, if I write on this side, what is the angle of this? What is the angle of this? You can subtract them, 2 pi. So what is that? 2 pi minus pi by 6. That is nothing but my 11 pi by 6. Fine. But you can see the direction of this is my clockwise. So what is the angle of this? It's a minus 11 pi by 6. So I can write this coordinate as r is still 2, angle is minus pi by 6 is also the representation. So you can see the polar coordinates are not unique. Another one, polar coordinates can also have a negative values. Again, you can see these two seems to be the different point, but if you draw on the polar coordinates, they are again the same points. How? Firstly, we can draw this point. 7 pi by 6 is a greater than of the 180 degrees, so lies in the fourth quadrant. Fine. This is my x-axis, so r is my positive. So in this direction, I consider this is my 2 here. Fine. Now we need a minus 2. What means? Firstly, we find the angle pi by 6. If I just continue this line to be here, what is this angle? This angle is my pi because it's a 180 degree. So what is the remaining angle? This is nothing but my pi by 6. Fine. Now you get as the pi by 6 on this line. This is the line of the pi by 6. This blue line is my pi by 6. On this line, can you find the minus of 2? Look at that. This is my plus 2. Why? Because this is the direction of here. If you take opposite of this line, what is opposite of this is here, and this distance is also 2. So this point is my minus of 2. What is the angle of this is? Pi by 6 is the required angle of this. So you can see, you can reach the pi by 6 radian angle counterclockwise, so it's a positive, and the initial rate 2 units backward called as the. So you can see both the points are my same point. So in the polar coordinates, every point has the infinitely many representations, because you can see here, you can write the another coordinates are, write all the polar coordinates of this point. So it means that's very simple. You can firstly write here. I will tell you the simple way how you can write all those coordinates are there. Firstly, you can take r is positive, r is negative. Second is theta is positive, theta is negative. So there are the four coordinates. Like when r is positive, theta is positive, r is positive, theta is negative, r is negative, theta is positive, r is negative, theta is negative. These are the four coordinates you can obtain. The first coordinate is given to be here when r is positive and this. Always find first coordinate you can find when r is positive, angle is negative. So how you make the angle as a negative? You move on the clockwise direction. So what is the angle of this? Can you find the angle of this? You can subtract from that 2 pi. So what is the angle of this? 11 pi by 6. So this coordinate has 2 comma minus pi by 6. Fine. Now the second point you can do as when you take r as a negative, r, what is the r is my 2. So you can take r as a negative, theta as a positive, r as a negative, theta as a negative. So firstly negative. So I can take this line. What is the negative of this? I can take this line as extended here. So this is my minus 2. Fine. Now you can write the angle of this. What is the angle of this when theta is positive, when theta is negative? So this is the angle when theta is positive. What is the angle of this? You can see this is the pi by 6. What is the angle of this? Is my pi. So total angle is 7 pi over 6. So this coordinate is minus 2 comma 7 pi by 6 when r is negative, theta is positive. So this is the coordinate of here. Second coordinate, this is my, when you can say that theta is negative, how you can do? You can find the clockwise direction here. So what is the angle of this? You can see up to this angle is my 7 pi by 6. Can you find the remaining angle? You can subtract as a 2 pi. So that remaining angle is my minus 5 pi by 6 is the required. So you can see both are positive, one positive, one negative, one negative, one positive, both are negative. Now these are the all the four coordinates are over the period 2 pi. This is the period of 2 pi. If you want to find more period, you can write all these coordinates as here. Or in journal, once you know this as a coordinate, you can write this is the positive. So you can write as a 2n pi. What is the minimum angle is minus 5 by 6 plus 2n pi as n varies from here. You can find the infinitely many polar coordinates. Look at this another one. Find all these polar coordinates of here. Again you can see here both are positive. So firstly you can write like here. Now firstly I can take r is my positive and theta is my negative. Can you make this angle as a negative? You have to move on this side. What is the angle of this? This is my 2 pi, minus of 2 pi. So first angle is my here. Can you take r as a negative? What is the opposite of this is? Here minus 3. What is the angle of this? You can move on this side. It's a pi. If you move on this side, it's a minus pi. Why minus? Because it's a clockwise. So these are the four coordinates of here. On this side, firstly you can write this point on the polar coordinates. This is my pi by 2 and 2 is my polar coordinates. Now you can take firstly r is my positive, angle is negative. So you can take this point. What is that? It's a 3 pi by 2, but it's a negative side. Fine. So this is my minus 3 pi by 2. What is the opposite of this? You can take as a r is negative. This is my minus 2. So what is the angle of this? It's a plus 270 degree. So it's a plus 270 degree here. What is the opposite of this? Is my here is a minus pi by 2 is the right. Similarly you can write here 3 comma pi by 4. This is my here. How you can make? Firstly r is positive, angle is negative. So you can make this angle. What is that? 2 pi minus pi by 4. So what is that? 2 pi minus pi by 4. 8 minus 1. 7 pi by 4 is the one coordinate. Second is when you take r is my negative and then theta is positive and theta is negative. When you take r is negative, then what will happen? If I clear this one, this is my negative this is my minus 3. So how you can find that? This is the angle. What is that? This is the angle of positive. So it's a pi by 4. This is my pi. So this is my 5 pi by 4. And what is the angle of this? Up to here it's a 5 pi by 4. If you subtract from the 2 pi, it's a 3 pi by 4, because it's a negative side, because it's moving the clockwise, so you can write as a negative. So the right answers are 7 pi by 4, this and this are. Similarly, you can write here, this is r is positive, theta is negative. You can write these coordinates. Now how you can write that? Firstly, you can make r is positive, theta is negative. So you can make theta is positive. How you can make theta positive? You can find this angle. This is pi by 4. What is the remaining angle is? You can subtract 2 pi by 2 pi minus here. So it is my 7 pi by 4. Fine. Now you can make as r is negative. So this is my r negative minus 3. How you make as a positive angle? This is my positive angle. This is my one angle positive. Another is my here. So you can see easily this is pi by 4. This is pi by 4. So you can easily calculate this angle as 3 pi by 4 and 7 pi by 4, because this is my pi by 4. This complete is my pi. So this angle is my 3 pi by 4. So this is my positive, and the negative is my, you can move on this. Okay. Now you can check whether this point lies on the curve or not. First of all, the first method you can draw the graph of this, but it is not an easy for you till date, because we will see how you can draw the polar coordinates in our series of the lecture. How you can say, if I say y is equal to x square is my curve, 1, 2 is whether lie on this or not. How you can say in the Cartesian coordinate? You can substitute this point here. You can see 1 is not equal to 4. So then this point is not lie on the curve. But this is not true. But we all know there are infinitely many coordinates corresponding to the same point. Look at that. If you look at this example, on this point, there are same coordinates of this single point. So firstly, we will check whether this point satisfied or not. How you can do? You can simply substitute here. You clearly says what is the cos pi is a minus 1. So 2 is equal to minus of 2, not satisfied. So what is the meaning of that? So the first look appears that this point does not lie on the curve, but this is not true. Why? Because this is only the one point. You have to look all those other points as well. So what is the polar? So it means firstly you can find all those equivalent form of this. So how you can find that? 2 pi by here. Can you find the equivalent form of this? When r is positive, angle is negative. So what is the angle of negative of minus 3 pi by 2? Fine. So you can write as a 3 pi by 2 is here. Similarly, when you take r is negative here, this is minus 2. You can take, this is my positive angle, 3 pi by 2. This is minus pi by 2 of the negative. Now these all are the 4 coordinates of the single point over the period 2 pi. Now we can check one by one. We can check whether this, because this point is same of this, and same of this. Check firstly whether 2 comma minus 3 by 2 satisfied. Again not satisfied. Check this satisfied or not. Now you can see this is satisfied. So hence you can say this point lies on this curve. But you can see this property is not hold for the Cartesian coordinates. When you are working on the xy plane, whenever the one point, because in the Cartesian coordinates points is always with a unique representation, but the polar coordinates it is not happen. So which is satisfied? So you can say this point lies on here. Remember, this is the supplementary point of this. So you can say this point is called as the, so you can say this point lies on this, and this point is called as the deceptive polar coordinates of this. Remember, because this is not the actual point which is given to you. So you have to find the equivalent form, and this equivalent form is called as the deceptive polar coordinates of this. There is no need to check about this one because this is already satisfied. Look at the one more example. Look at that. If I consider this example, clearly says the first look will appears whether it is satisfied. Firstly, you can draw the graph of this. 3 pi by 4 is here. R is positive right here. Now you can see this is my 3 pi by 2. What is the 3 pi by 2? You can see it is a minus of 2. it is not true. Again, you can never say that this point does not lie on the curve, because the polar coordinates, the representation of the polar coordinate is not unique. So can you find the other coordinates of this? So firstly, you can take r is positive. What is the angle negative? This is the angle negative. So 2 pi minus of this. So it is my 5 pi by 4. These are one coordinates minus of this. Fine. Other is when you take r is negative and theta is positive. So this is my r negative minus of 2. What is that? Angle is this angle. So if this is 3 pi by 4, what is this angle? This is my pi by 4. So this angle is minus pi by 4. And the second angle is my here. So you can coordinates of the other are my here. Remember, this is my pi by 4. Fine. So this is my minus pi by 4, vertically opposite angle of the other side. So this coordinate is minus 2 minus pi by 4. Now check one by one whether this satisfied. If any one of satisfied, then you can say it lies. If none of them will satisfied, we can say it is not lie. So you can see the first point, sine 2 pi by 5 pi by 2 is a 5 pi by here. So how you can do that? I can written as a sine of negative is my negative. So 2 pi plus pi by 4 is my minus 2, which is not satisfied. Look at the second point. Again, you can see now it's a satisfied. So it means this point, you can say this coordinates is lies on here. And this point is called as the deceptive polar coordinates. So you can see, yes, this point lies on this curve. There is no need to check, but if you want to check, you can do also. There is no problem. Again, check whether this point lies on the curve or not. So this point is 3 pi by 2 here. R is my positive, so in this direction here. If you substitute this point here, again it is not satisfied. The right hand side is my minus 1, but left hand side is my 1 by 2, which is not true. So you can write all those polar coordinates. How you can write the polar coordinates? When r is my positive, then what is that? R is positive, so what is the angle of this? It is my minus pi by 2. Fine. So what is the other one? If you take the opposite of this, it is my minus half. What is the angle of this? This is my positive angle. It is my plus pi by 2, and other is minus 3 pi by 2. So you can see it's a my minus half. Positive angle is my here, and negative angle is my this side. Now you can check one by one here. The first point is my which satisfied. So there is no need to check for the others. So this point is called as the deceptive polar coordinates. If you want to check also others also, you can see the second satisfied, the third is not. But you can check only one of them, that's more than enough. Now, the second one is conversion of the Cartesian coordinates to the polar coordinates. So we all know if you write the x and y axis, if any of the point x comma y on this plane x comma y, such that the distance of this point, say m is my here, the distance of this is my x and y, and this is my polar coordinate of here. When they are equivalent, can you find this value of the x in terms of theta? You can easily see x is my r sine theta cos and y is r sine theta. You can scaling and adding, and then you can divide, you can write here. So it means whenever you want to convert the Cartesian coordinates to the polar, you always use this transformation. So can you say here, what is the value of the r when 1 comma 1? You can see x is my 1, y is 1. So r is my root 2. What is the theta is? Tan inverse 1. So that's a pi by 4. So r is my this, theta is pi by 4. So polar coordinate is my here. This is the one point. You can find the other coordinates as well. When r is positive, theta is negative. When r is negative, theta is positive. R is negative, theta is negative. Now this is already a polar coordinates. Can you convert into the Cartesian coordinates? You can substitute what is a r cos theta, that's a x. So this is nothing but x is equal to 2 is the equivalent form of the polar Cartesian coordinates. You can convert both way. Can you convert into the Cartesian coordinates? I can find the value of the cos theta is x by r. Sin theta is nothing but my y over r. If you substitute here, which is nothing but my xy is equal to 3, which is a rectangular hyperbola. if you want to draw the graph of this, which is again a rectangular hyperbola. Similarly for here, how you can do that? I can substitute the value of r here. What is the r cos theta is nothing but my x, so you can write as my here, which is, you can see that it's the equation of the circle. So what is the polar coordinate of the 0, 0? That is the origin. So if you substitute here, r is my 0, that's fine, but what is the value of the theta? Theta is not defined because it's a 0 by 0. 0 by 0 you can't define as, so it means for any of the angle. So that means the polar coordinates of the 0, 0 is any angle. You can take angle as a 0 degree, you may consider as a 15 degree, you may consider as a 30 degree, you may consider as a 10 degree, all are my polar coordinates of the origin. So polar coordinates of the origins has infinitely many values. Look at this. Can you convert this polar equation into the Cartesian coordinates and then identify the curve? How you can convert them? That's again a simple. You can substitute these points are there. You can see, you can substitute these points. X is r cos, y is r sin. So you can see here, x square is r square. You can substitute here. So this side is nothing but my x square plus y square. This is my x, so you can write here. Now you can see, you can simplify this like of here. You can completing the square by adding 4 on the both side. You can see here, which is nothing but the equation of the circle. Center is my 2, 0, radius is my 2, 2. So you can see, you can easily draw the curve if you want to draw the curve. Center is my 2, 0, and this is my equation of this curve. If you want to draw the curve, which is again the same as here. Can you find the curve? Identify the curve and the Cartesian coordinates. So what you can do, you can substitute the value of the cos theta is my x by r. So it is 4 over 2x over r minus y over r. So if I take the LCM and then multiply them, you will get as here. Or you can simply substitute the value as of this. What is that? This is the equation of the straight line which passes through. What is that? When y is equal to 0, x is my 2 and so on. So you can convert all these polar equations into the Cartesian coordinates and identify the curve. That's very simple. For example, here you can see this is the cosecant. So what is that? I can write as a 4 sine. So I can multiply them. R sine theta is nothing but my y. So this equation is my y is equal to 4. This equation is my x. So x is equal to 0. I can substitute x, r square is x square plus y square. You can convert this into the sine and cosine, and then substitute x is r cos and y is equal to r sine, and so on. Here you can substitute r is, that is the root of the x square plus y square, and then you can substitute what's the value of the r is x square plus y square. Then you can find here. So that's an exercise for you. You can find here, you can substitute, you can open this bracket, sine a plus b, and then you can write here. So I hope you can simply learn the concept of the polar coordinates in a very simple manner. We will see the next lecture how you can draw the polar graph. That's the most important topic, how you can draw the graph in the polar coordinates. So far we have seen the representation of the polar coordinates. Next lecture we will draw the graph in the polar coordinates. Till then, I hope you can simply like, you can share my videos with your classmates. Best of luck students. Happy learning always.